to today's podcast. We are excited to have with us a true advocate and expert in RISC-V ecosystem, Paul Sherman. Paul have been a prominent figure in the RISC-V community for over 6 years, actively contributing to its growth and development. He played a pivotal role in academia and training committee of RISC-V International, where he helped create first RISC-V 101 presentation, which debuted at the 2023 RISC-V Summit, and he also launched the first RISC-V contest in early 2024. Paul has a wealth of experience in hardware engineering field, having worked as the director of hardware engineering at GoQS Research Laboratory, where he built a state-of-the-art hardware validation lab. He has also spent hardware uh, He's also spent nearly 8 years at Western Digital, where he created and architected embedded firmware for advanced magnetic recording. So today we will dive deep into Paul's insight on RISC-V ecosystem, its challenges, opportunities, and the future of this open architecture. So join us as we explore how RISC-V is making the waves in the tech world with Paul Sherman. Welcome, sir. Would you like to introduce yourself?
Mm, you did a great job, Anushka. Um, yeah. I guess how I could best introduce myself, except you know, um, any better than what you just said there. I've been in data storage um, since my whole career, which is 1989, 1990. And I've always been a test engineer. I've always liked playing with hardware. If you wanted to see um, a good reference, can you put in the chat window for everybody, Anushka, the book that you can read to get some good background on test engineering or hardware from my data storage background is
Yes.
called Hard Drive the Novel. I'm not sure if it'll share the screen. Um, how to um, let's see, where's the chat link here. We'll just put in the chat window hard drive the novel.com.
Yeah.
That's a good book. um, the I guess background before you have questions to ask me. My background playing with computers started with the PDP-11. Is that showing on the screen there? And as you know, the PDP-11 mainframe and is the DEC instruction set architecture that was first developed. And as all my early elementary school days in Berkeley, University of California, Berkeley in the hills, there's a Lawrence Hall of Science that happened to have a bunch of ASR 33 teletypes with the paper tape reader connected. You would connect with a dial-up modem to a phone bank of dial-up lines into the PDP-11, and then later on in the 80s, late 70s, 1980s, the Intel came along with the 8080. And I don't know how many people have seen either IMSI 8080 or Forrest Mims's first computer, the first personal computer, the Altair 8800. What's interesting is at the end of the podcast, I invite everyone to go watch the movie War Games with Matthew Broderick and Ali Sheedy. It was a 1983 film. Reason I mention that movie, if you look very carefully in the bedroom in the back is the IMSI 8080. with the front panel switches. And so that's kind of the start of it, and that's how I got my start. And later on, uh, Synertech and Moss comes out with, you know, if you go back to RISC-V, you know, of course, that was in 2010, started with David Patterson and Andrew Waterman. Before that, there was RISC-1 that David Patterson created about 20 years before that. But I would say RISC-0 really is a 6502 that came about from 8080. There's a little bit of history that people from Intel got discouraged and started the Z80, Zilog. And what's the difference between 8080 and Z80? One instruction, EXX, register swap. That made programming, embedded programming, very easy because you don't have to do any stacking of registers. So beside that, people wanted something very small. There was Commodore that made this commercial appliance for people to either learn computers or play games with or go further. And then Wozniak, as you know, made the famous Apple equivalent, both 6502. And so that's my history that I would add to what you said for my kind of professional background, Anushka. And
Yeah.
just to remind you what RISC-0 is, it's three registers: is accumulator X and Y, and not many instructions. And that's, you know, again, 56 instructions, three registers, and just keep that in mind when you read about RISC-V. RISC-V has 32 registers and probably even less instructions. I think the I extension is 37 of them. So, any questions, and people can talk.
So do anyone have question up till now related to 6502 or
Or the
RISC-V
ASR33.
history? So let us start. So does RISC-V see ARM as a competitor?
Hmm. Tough question, Nushka. I would have to say that it's more of a companion, that RISC-V can't be, you know, I would say nothing can be everything to everyone, or at least quickly or immediately in the short term. There's some slow evolution that has to ensure. So I would say that ARM is a great companion to RISC-V because it uh, allows the continued innovation development of what's already out there. Like, you can't replace every peripheral and implementation to an ARM core, you know, replace the AMBA and the embedded trace macro cell buses and things immediately overnight. And so, you know, there are things that ARM does well and is fully entrenched in actual workings in products. Um, in some cases, it's nice to have instructions that are complex, you know, that do many things, that are self-contained. So not so much a competitor. I think it's a help.
Yes. So why RISC-V growth has been China-centric? Yes.
Or at least that's the impression. I don't think it's by the intention of RISC-V or RISC-V vendors or the foundation, but just where the greatest adoption is. The Chinese government and public academia has put in great efforts and in great investment, like the PLCT labs, to develop and the learning and the engineering capabilities of RISC-V. I would say that it's not only China, but Europe, China, and India. Like in Pakistan, the 10x engineers. Um, it's whatever group or area contributes the most to the RISC-V Foundation, which is for individual members, free and open to all. Like Anushka,
Yeah.
go to riscv.org, click, sign up as an individual member. It's free, and start attending committee Zoom meetings
Yeah. I'm
and
sure that
organize a group
also.
of friends and get a small group of people working together. And then that, you know, will be a good, a large growth part there. Brazil is also getting as very popular now as China. Yeah.
Yeah. So what are the key ISA specific challenges for RISC-V?
Mm. Yeah, tough questions you ask. Uh, um, uh, just, I might have to say, when when you work with a standard, or when you put an abstraction together, and you start, you develop a set of primitives, and you're working with your model that you've architected. As you evolve or add more to that, the challenges are not duplicating what you've already done. And so now, the the instruction set architecture of RISC-V is designed to be modular, and as more functionality is being talked about, or things thought about to add, is the challenges are making sure that there's no duplication, or there's no um, backwards compatibility that's being ended, or stopped. You, in other words, when you start from nothing, it's very easy because you have nothing and you can just create and innovate. But once you have something established, it's more of a challenge to keep within the same framework and structure, so you don't end up with a huge mess, layers on layers of incompatible, or design things that don't really synergistically connect with the original intents. You I guess in, like, the Windows operating system, you have a large bloat of code that, as years and years have gone on with different versions, there's different device drivers, different aspects that have to be left in place for some compatibility, or there's things that are end of life that are now made not compatible. And so the biggest challenge, I would say, is keeping the the framework and the ecosystem of the ISA smooth and stable, and sort of consistent.
Yeah.
Yeah. And it's not just a technical aspect, Anushka, but it's more social, because, like, if I ask anyone here, who owns RISC-V, what company owns RISC-V, the answer is none. You and everyone here owns it. It's community driven. And so the challenge is keeping with the original intents, and sort of not duplicating what's there and not breaking what's behind, and doing that while working with other humans.
Yeah.
That's the high challenge.
Yes. So
Oh
Joe,
yeah,
you want to have the question on this?
yeah, Akash.
Sir, as in ARM processors, we are having this bus architecture, AMBA bus, AMBA. architecture, bus architecture, that is very fast. So how are we gonna look into this RISC-V thing?
This the speed of the AMBA, and you mentioned earlier the as we were talking about the tile link bus, just community participation, and just get a bunch of people together, sign up in Anushka, show Akash how to start attending meetings and evolve and drive the specifications that will make sure that the RISC-V buses are, showing good performance and designed with, good extensibility.
Yeah, you showed me that website, no? That RISC-V technical meetings.
Yes. Once you join, a member, then I know. Can you see? Am I sharing the screen here?
Yeah,
Uh,
you need to share the screen.
yes. And I shared it again. I think that's just share the whole tab. Yeah. Okay. Tech dot, and it's very hard to find this link. tech.risc5.org/calendar. There's a way to get it, but leave that up on the
Your
screen.
screen is not visible.
Should be. It should be.
Yeah, now it's there.
And is the link bar? I don't know if the link bar came in. Share the whole screen, the entire screen. Get. Well, this was in um, in in response to the question about how to make sure the RISC-V interface has, similar or comparable performance to AMBA, the AMBA bus speed and all that, and how to make sure is through community participation and joining the foundation as individual member or university member or corporate member, and forming committees and discussing, proposing new specifications or changes to specifications to ensure that. And how to do that is joining riscv.org as like an individual, as a member, and attending one or more of the committees, or looking at which user group is it applies to that. And if nothing is relevant in the meetings that you see in the calendar, then maybe a working group needs to be formed for something that doesn't exist.
Yes.
It's all community driven participation. Uh, then remember that RISC-V is an open standard. It's not so much open source, but it's the open standard for processor cores that can easily be implemented. Of course, getting something in silicon takes money and working with the foundry. So probably the easiest first step for demonstration is the soft implementations, the FPGA the real world FPGA as opposed to something on a simulator. And uh, but again, implementing or testing out an idea on an FPGA is not going to show the full performance, right? Because just the nature of how it's not, the FPGA is not, you know, the same environment.
Yeah.
Clocks run slower, and so you'll you'll test the idea, but not the full performance. But FPGA is getting better.
Yeah. So
Go
what
ahead.
are your views on open source EDA and how is RISC-V helping in the evolution of open source EDA?
Yeah, that's one that I like. As much as I haven't worked too much with the synthesizing of cores and designing of internal hardware, um, the one aspect that I fully believe that RISC-V really helps with that, I'll put in the chat window, is open source tools like Scala and Chisel. As every, have you heard of those teaching tools from Berkeley that are quite powerful? And if you look, like for example, the entire layout of a very elegant, one of the first RISC-V chips done, that is the FE310, that was done by Sci5. Look on Google. I think you can find the link. It's a GitHub link. Scala FE310. If you do a little internet search, Anushka, you'll see, I think it's a GitHub site called Sci5 Freedom. And all the set of files for implementing that core is open source hardware definition language, as opposed to the Synopsys or the Cadence or other proprietary tools, so that anybody can work with that. A big contributor to RISC-V is, I think it's Chips Alliance. Have you heard of that?
Yeah.
The Chips Alliance group, especially, I think there's a lot of European people, contributors in Chips Alliance, doing incredible things with open source EDA tools. And so Chips Alliance is a side foundation that is a very strong contributor and companion to RISC-V. And so RISC-V really is enabling a whole ecosystem of providers.
So were you talking about this FE310 link on GitHub?
Yes, and you'll see files of the Scala and Chisel layout of how that little first single core 32-bit IMAC little core is developed. The whole thing done as a teaching tool. So Scala, Chisel, probably the best point to look at would be Chips Alliance, because they have a whole lot more than these two teaching offerings. That's it. Yeah.
So what are your views on open source verification tools for RISC-V?
Well, like I mentioned here, um, yeah, the tools. that I just mentioned here, and also what I've always liked, being a non-mouse, non-screen person, CLI, open the DOS window, open the command window and use VI, for validation, verification. Um, I know it's painful, but the more you type out a single page or a single sheet of code, the better. The more you learn. Kind of like Jane Fonda's "No pain, no gain." That uh, keeping for validation verification, keeping your work small, modular, and easily managed. When you're in test engineering, we have procedures, test procedures, and I've always liked in my whole career to follow the style of one procedure per page and one step per line, and things that you can type on a CLI. Devise, think about what it is you want to validate or verify, and make up a set of primitives or primitive functions. Just layer very carefully how you want to design that, and so you just maintain a good fundamental knowledge that you always know where to get from. And the command line interface is inherently free, part of whatever operating system you're using, even if you write your own little parser.
So, what do you perceive as the biggest challenge for open source EDA?
Mm, humorously, the large amount of marketing and push from the non-open source proprietary vendors. Synopsys and Cadence and the others are very popular, very powerful, and very expensive. And the biggest challenge is the marketing is vicious. So the biggest challenge is all of you here in school and work. The biggest challenge is what is being taught in school. Are you given a Renaissance board to learn or work with, and told to told to use a Synopsys tool with that Renaissance board? Or are you in a class and the professors and the curriculum is designed around Arduino or open source tools? So I guess the biggest challenge is, the incessant and very persistent, powerful marketing from the proprietary expensive vendors, and also the the pushing back and desiring of good agnostic basic abstract tools being taught in the schools. Like used to be, you would learn data structures, algorithms, basic things in computer science with the core textbooks. I can remember Tannenbaum computer networks, Tannenbaum operating systems, Arthur Tannenbaum's text. And nowadays we have LabVIEW and MATLAB and Mathematica. The proprietary vendors tend to give educational discounts and free educational versions, so students learn that specific style of work. With sort of you graduate a 4-year college learning how to use Synopsys, but you're beholden to the Synopsys way of doing things. And so I I've always felt the biggest challenge is staying agnostic and staying general.
Yeah. Like you were saying that the colleges should introduce open source tools, right?
You're right. And open source concepts and doing things yourself, reinventing the wheel. The biggest way to keep open source open and keep it going is use one of these things. The never needs batteries, and doing a lot of writing and typing and retyping. How many times have we retyped Conway's Game of Life as we learn AI? Um, sort of. I, One of the challenges as a teacher, it kind of gets boring if you teach the same thing over and over again. Teachers have to think of new ways to teach so that it's never boring. So that's a challenge. But um, not relying upon, not trying to mix um, commercial product that's already done with students or young engineers that are trying to learn. You want to learn how things are put together. You don't want to learn how to use something that's already put together.
Yeah, but these days, eFable's open source tools are also getting very much popularity. Many students are going for tape outs.
Tiny tape out, eFabless, right?
Yeah. So RISC-V was born at Berkeley University. So how can Indian University contribute to this open source hardware movement?
Ah, easy one, and I'll let you answer that, Anushka. Um, ac- Sign up as a member on RISC-V.org and join the academic and training committee.
Can you
Like,
share the website? Can you share the link here?
um, well, it's on the calendar that you have. The main. Um, I'm scared to put RISC-V.org because the website has just been changed in its layout, and it's a little bit hard and not fully implemented. If you look at tech.riscv.org, that's a little more complete collection of information there. I think riscv.org is functional enough. You'll see the link that says join.
Yeah,
So
wait,
what
let me
can
check.
universities do is join and be part of academic and training committee and get see how to get us events and small clubs together. Now, what can be done practically, like even faster than that, is um, look
So,
to look start thinking about how can you create offerings like the Arduino or Michael Welling's Low-Fi board, something very simple. I know ESP32 has something like that. Raspberry Pi has the Raspberry Pi Pico. Um, but how can you do something like a very simple Arduino? That means not just making a circuit board and putting a schematic together with some firmware, but making documentation available. Arduino had very simple documentation. When you look at the user manual for the ESP32C6, it's over 1,200 pages, over 1,200 pages. And it's very, maybe complete, but very redundant and hard to follow. What made Arduino nice is that teachers with not a lot of time and not getting paid a lot of money could adopt the Arduino into class curriculum easily. And that's why I guess ST microelectronics. Remember the STM32, right? Uh, ST microelectronics offerings was a little bit more popular than NXP. And NXP and the Freescale offering, with their what is it, LPC espresso offerings, a little bit less comprehensive documentation. It was very difficult for faculty to create curriculum from the LPC, like LPC 1769 chip, ARM chip. But Arduino did well. Or that was ST Microelectronics' documentation was very, very simple. I never liked the Cube MX offering to put things, together with all the many versions. But so, what can universities do aside from being members like you, Anushka, for of RISC-V is think about how to create not just simple hardware, but well documented ones.
Yeah, that's true. We need to develop a good habit of developing very good documentation. So here, where you said how to join the community here.
Right.
You said that we can join various RISC-V group like different RISC-V SIGs. So where to join it?
Yeah, that not even look to
I think it is here in this documentation.
where that put is. You see the
Is the
ratified
screen
specs,
visible?
I'm sure.
So yes, here.
I think you might have to log in, which means you have to be a member.
Yeah, I'm
You
already a RISC-V member.
to see the list of committees, you might have to log in first. See the horizontal committees, the steering committee.
So here it is, that committee you were talking about.
The working groups,
Yeah,
right?
here we have the subgroups.
Yeah,
So this is the RISC-V main group.
you might want to put a link to that, how you found it, because that's difficult.
Yeah. So this is the document. In this, they have given the complete method that how you can join the RISC-V community. And here is
And
that
notice
link.
one of the working groups, one of the committees is the documentation committee too,
Yeah.
which shows how important documentation is. The committee for that's discussing how the unprivileged spec is to be presented. How should the privileged spec be presented? How are profiles or groups of extensions, which are groups of instructions, how are profiles to be documented? There's a whole documentation SIG committee as well.
Yeah. So a few years back, India had microprocessor challenge, which saw hundreds of participants, actually thousands of participants. So, but despite government of India efforts to push RISC-V, we do not see RISC-V gaining traction in India at the expected rate. So, what
Hmm.
can be done to make RISC-V more popular in India? So, what's your view is that if we search for Google RISC-V trends, so China is on the top of the list. So, what's your views on that?
Yeah. Well, of course, we're using Google Meet because you like Google, Anushka, and here's where we uh, kind of disagree vehemently that determining popularity by a Google search, I would say, is not a good idea. Just because even the internet search, how many people have found that SEO and web search has been compromised and polluted. When you search for something, you'll almost not get what you're looking for at all. You'll get whatever advertiser has paid the most for Google AdWords or keywords. That if you really want to gauge the popularity, what I've found, not for RISC-V, but you would say RISC-V, India, uh, and not to give any credit to Reddit, but um, put the word Reddit at the end of a search. In other words, you're gauge. I'm trying to say that just because a Google search shows China or Europe as the top contributor to RISC-V, don't let that mean India or other places are not on the map, because um, you know I'm saying don't take Google search as the de facto metric of goodness, and um, and so there is, like I said, India is such a big player already. I think there's a summit, there's a European summit, there's the Asia China summit, and I think there's a either there is or there will very soon be the India summit too. So it's a very strong player. But
Yeah.
just the appearance of not being strong is an internet search engine problem. And what to make sure that India stays as a strong player is adoption into academia. Make sure there's a lot of Arduino like boards and material that is easy to understand and accessible for everyone. Like I come back to Michael Welling's Lo-Fi board, which was based off of Sci-Fi's Hi-Fi board. Do you see do you see a USB? Is there a USB connector on that? No, not at all.
Yeah.
And and the um, the we know as a USB connector, ESP32C6 has a USB connector. They have, you know, you want to make a board easy to use. You'll you'll
Your
integrate. You'll
video is
integrate.
not visible.
Hmm?
Your video is not visible actually.
Hmm. Yeah. Hold on, just a sec. Yeah. So yeah, I guess what India can do is like what anyone can do is is make make simple offerings that are modular and separate, uh, uh, separately connected. Let me share another screen that comes on that point of what can be done. Um, okay, you're sharing. You seeing the screen share here, right? That's the
Yeah.
RISC-V. All right. Okay. Now how I learned Thai. That is what you have two alternatives. You either have the fully integrated all-in-one approach, like Arduino, within onboard, fully integrated USB interface, and making things easy to set up, plug and play. Everybody's seen plug and play a lot, right? And the alternative is the some assembly required component stereo system alternative. It's flexible, free, easy to learn, open standard, piece by piece. Takes a little more time to connect. When you you get a new DVD player, it might take some time to reinterface, move cables and wires around. You never look behind. It's a mess jumble of wires if you don't take the time to make the wires look nice. But thinking of that would probably, in my opinion, be the way that India can be a strong player. It's that create an ecosystem of different levels of RISC-V learning tools, either books, documentation, modules. Um, not again. Remember, like I said about learning in computer science with MATLAB, and always a student graduating a four-year college being beholden to only being capable with LabVIEW and MATLAB, as opposed to a student going through the basics of data structures and algorithms and knowing how to write out Huffman coding by hand, from scratch. Uh, that thinking and providing or creating modular like offerings that like if you can see on my video here, Michael Welling's board had the interface is 4 pins for JTAG, industry standard JTAG clock, TCK, TMS, TDI, input and output. Your 4 basic JTAG pins, power and ground. And so, if you want to come, to using this or learning or working with this with a Olimex interface or FT232 interface or Raspberry Pi doing bitbang JTAG, you're free to do that. Your hands are not tied to whatever the manufacturer of that board wanted to sell at some particular point in time. The difficulties are is what how is the standard created, and standards make innovation slow because you have to talk with people and talk with other companies, and so you have to work together, but standards you know that allow great growth and solid um, um, growth potential.
Yeah. So these days we are able to see the cheapest RISC-V chips by China, that is CS32V003. So is it good for beginners, students like me to learn that board? So
That's what exists. Yes. Um, no, not a good idea. To be frankly honest, Anushka. Um, that's why it's a little bit older. The 2017 the FE310 that anybody, and the little bit I can understand, I've looked into that to figure out how it works. Um, you if you look, you know, China and Europe are, you know, learning themselves, and I guess it's fun to play with, like the CH32V003. It's a lot we can learn from, but um, know that it's it's very difficult to learn from something that's made by other people learning also. Just something you have to keep in mind, that it could be difficult or sometimes painful. That, you know, not to say that we shouldn't explore or learn, like the ESP32C6. A lot of documentation that, let me throw this out to you. Um, the China offering that comes from WinChiphead, I think the company is called what? Quinhang,
WC
QINHENG,
Link, WCH.
or WCA WinChiphead, or the WinChiphead company, from what I've seen, is called Quinheng, QINHENG. Um, that what you could learn from best, Anushka, is um, look for offerings that are uh, performance or capability heavy and peripheral lean. Perform Capable heavy, perform and peripheral lean. In other words, something like the Sci5 SIFIVE, the FE310, which was the high five one board, um, it sort of came out from the very creators of RISC-V. That was a Waterman, Christy Asenovic, Yunsup Lee design, Megan Walks, and there's not a whole lot of peripherals. You don't see Wi-Fi, you don't see Bluetooth, you don't see the peripherals of accelerators for um, uh, um, compression processing in there. You don't see an analog to digital converter. Is not there. The only peripherals are an SPI, an I2C. I think there's two UART ports, a GPIO, and that's it. And look for something with, and by the way, the core that's implemented, it's a 320 megahertz high-speed clock, PLL, and a 5-stage pipeline. Pretty advanced. And this was in 2017. That 2017, one of the first chips that came out was an implementation of a 5-stage pipeline with the full implementation of the A extension, the atomic, I mean AMO, and the load reserve store conditional, which is still being implemented by a lot of China and other suppliers for silicon now. But full capability of the core ISA specifics, but pay attention to something that's GPIO, SPI, I2C, UART. Maybe that's it or less. If you look at the CH32V003, there might be an underlying 8051 subprocessor core in there. I think that all of these other WinChip head and Espressifs, look at the peripherals that they have, and you'll see Bluetooth, Wi-Fi. You'll see lots of other peripherals, but then I think the ESP32 is only a 3 or 4 stage pipeline design. Um, I put together a block diagram of the SoC. Everybody knows an SoC is a system on chip, right? You can see my screen, right?
Yeah.
Okay. So how RISC-V fits into that, I put these two pieces together. Both on the right hand side of the page is a picture, say, from the FE310, and that follows the unprivileged. Again, if you anyone had to ask, where do you go to learn about RISC-V? And that's three things: the unprivileged spec, the privileged spec, and the debug specification. Throw debug in there, because the first two is for the core, which on the right is shown in yellow, and the debug module is that small green box, but that comprises the SoC. The left side of the picture, the yellow CPU, is a small, well, somewhat smaller yellow box, and all the rest of it is the debug module. And so you can see the debug specification down there in this version. And that vertical double-headed arrow between the debug transport module DTM and the transport hardware, that's the four wires of JTAG that go to whatever USB or whatever interface you're talking to. And so that's all in one chip. And SoC is the debug plus, or the interface to the core. And look at the peripherals. If you look on the right hand side where it says GPIO complex, you'll see UART, pulse width modulation, SPI, quad level SPI. That's it. You don't see any DAC, no analog to digital converter, no CRC32 accelerator engines, no uh, transmitter receiver Bluetooth things.
But
All of this,
I had a question in this,
yeah.
that as the need of embedded system is growing, they are getting advanced day by day. So we need features like Bluetooth, Wi-Fi on a microcontroller. So why having not these features in this chip is a good thing?
Uh, I, I think it's a good thing having them through the interface. In other words, not on chip, but as 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 component, you know, points to be easily connected to, so that you know, that a chip can focus on what it does best and not be totally integrated.
Yeah.
You know, that we had before integrated circuits, there were discrete transistors and and components, and then through integration, we start putting transistors on silicon and making integrated circuits, and then small, SSI, if you're old enough to remember, then medium, then large scale integration. But um, think about it, I guess, right now as keeping silicon a little bit separate and modular, not trying to put everything together close to the core, but more. You see a lot of people doing multi-chip modules or chiplets.
Yeah, chiplets is very much trending in semiconductor industry.
And it makes it easy. Again, I think it goes back to my see a little picture. The chiplet allows you to to keep the amplifier and the tuner and the cassette deck the same, but change the reel-to-reel tape recorder to something else, and you don't have to replace your nice fancy tube type amplifier, and that's working well and sounding good, um, and keeping these components. Plus, you you can evolve to the latest technologies of Blu-ray, DVD, or Blu-ray, or beyond that, but still utilize a lot of the fundamental basics of the way the sound from your tube type amplifier sounds. And that's kind of the same way that I feel, yeah, that everybody likes to have Wi-Fi or Wi-Fi 6 or Wi-Fi 7, you know, without trying to put that uh, on the same core and or silicon and connection, means that whatever work you're doing with the core or putting, if you look carefully here, that's one a little bit of layers um, of vectoring here. The processor can have many cores, and a core can have many hardware threads, and so that multiplicity, you see the multi layers on the left hand picture, yellow box. You see the hardware thread is inside of a core, and you have many cores in the SoC. That multiplicity gets kind of complicated, and if you have to work that together with your peripherals, you know, the the somewhere the efforts to understand or properly evolve that and keep it simple, um, you know, one or the other aspect is going to be lost. Yeah, and so maybe if you need to do high speed Bluetooth activity through I2C and I2C is not fast enough, maybe devising a fast GPIO link or some fast PCIe or high speed direct tile link, AMBA equivalent bus is a future that like that. But certainly from the standpoint of just learning and working, and again, academia making it possible for students and young young folk to learn, you know, learn in a modular, separated sense where you're you're doing a lot of things by yourself. You only learn the best by doing it yourself.
Yeah, very true.
No matter how far advanced we want to go or how you know it's remember speed of learning and progression is something only from a capitalist perspective. When they say time is money and we need to make profit, I've always felt that no, time is time and money is money, and
So, in your opinion, can RISC-V architecture be used for SIMD style accelerator design?
what type of accelerator design?
SIMD style.
Oh, the single instruction multiplier. Yeah. Yes, it is. Look at the vector extension, and if you go back to your the list of user groups, there's the not only the vector extension of instructions that is agnostic to the length of the vector. Single instruction multiple data is limited to, I think, how many elements of multiple data are being affected by that instruction. The vector instructions, um, the length of the vector is a parameter as one of the operands. Not only the vector instructions are being worked out and put in place of RISC-V, but there's a very newly formed set of instructions to handling
Yeah,
matrix operations.
yeah,
So it's not just multiply accumulate. That's what the single instruction multiply data is, right? But it's multiply accumulate, automatically handling the rows and columns in a matrix form. That Rivos has been doing some very good presentations and work with that too. The company RIVOS. Yeah, so I'll put that in the chat because it's look at the RISC-V matrix extension, and that's and all the company that was doing that is I think Revos is a strong contributor, and that's one of the user groups. And so, if SIMD is an interest, yeah, that's where to start participating.
So, yeah. So, so ARM dominates the mobile space while x86 is king in desktops. So and servers. So what does RISC-V need to do to challenge these established architecture? Do you think there's a room for RISC-V to carve out a niche in the mobile or PC markets?
Hmm. I'll go back to my. I never remember I said my background was 6502. And when I joined Western Digital recently as a test engineer from 2009, um, the test equipment that I was evolving that had already been used, I think it was an analog devices chip. I was uh, the test board. I've always designed my own equipment in house, and and that goes back to another point, Anushka. Um, sort of my philosophy and everything I've worked is you could either use something that's off the shelf or you could design, take what there and design and use something that you design, you put into practice. Then you have total knowledge and total control of how it works, especially in test engineering. You as a test engineer, you're responsible for creating the measurement tools that are used to gauge some other part of what's being made, pass or fail. So you're designing the meters and the instruments. And the first core that I was tasked with understanding with analog devices, I think ADUC 7026. It was the ARM7 TDMI. So I thought that's strange. And then as my work progressed, I noticed that there was two different types of ARM cores. There was the ARM7, ARM V7, ARM V8. How many people fully understand the naming between the V style numbers, and then when you say like the Cortex family, like Cortex M M3, R4, like that, whatever, ARM7, ARM9, or one is the architecture name and one is what implementation name. Never understood that. But there's a lesser known sort of flavor of ARM or the Cortex family for predictive handling of execution time around branching and branch prediction, and that's the R family. Not very popular, right? Cortex Cortex M was a small ARM core designed for microcontrollers like washing machines. The Cortex A family was made for applications, right? Multiprocessor, multitask operating systems like what's in all the smartphones. And then the Cortex R was for very time consistent and time deterministic execution, especially around branching, for motor control applications. And inside every hard disk drive is the Cortex R family. And so there are these different fundamental flavors in RISC. RISC-V doesn't really have these three different types. These Cortex A and R and M are very different in how they work. RISC-V is all one and the same. It's unified, it's homogeneous. There is only one, and what makes a difference is what extensions are built into the core. And I'll only mention one word, like I said, profiles, to make it easy when you specify you're gonna you put in atomic circuitry that implements the atomic instructions. That's what you want. You're gonna put in circuitry implements 1024 length vector instructions. You know, you have an alphabetic list of your like RV64 64-bit register uh, um, um, implementation with IMAC, and running out of letters, you see the extension named with beginning with the letter Z, like ZLRAC, a whole bunch of line of Z's. Namings of groups of extensions of instructions have gone to profiles. Similar to ARM, you'll see that when RISC-V Foundation has a product release, you might see some advertising or some mention in the news about now RISC-V has ratified the specification for RVA 23. And so that the 23rd version, not necessarily 2023 year, RVA, not to be confused with the application processor, but RVA for something capable to do multi-processor operating systems. And so to come back to your question about how can it handle all these different tablet or desktop PCs, just through very good naming and and tying together of the different letters that represent the the specifications. I showed that to you earlier. I can share the screen again. What I call is the RISC-V song is you have that Anushka, or
Yeah, you sent me earlier.
yeah, is sort of I call it the alphabet song, that all the little extensions, if you a micro Cortex M, a microcontroller ARM equivalent space might include like on the right hand side, when just in time garbage collection, thinking Java, if you wanted to make a RISC-V project, core project to run Python or Java, you would have, there's instructions in the J extension to handle like a garbage collection, the in a nice way, extension J, um, or like many dimensions handled by extension V enable AI, as you also, because AI is multiply, accumulate, handling weights in a neural network. I just put this little rhyme scheme together, and the naming to make it easily understandable in the context of where we are now with ARM and portables, mobiles, desktops, is the RISC-V profiles. That was another thing. Look, and it's a little bit abstract. So look at the RISC-V profiles and naming for that.
Yeah. So Sandeep and Roy have a question.
Yeah, Sandeep.
Hi, I wanted to ask a question from the previous topic we just came across.
Okay.
Since you answered the question on the SIMD capability of RISC-V, I want to ask you how you see the scalability of a RISC-V processor for an actual accelerator for any specific architecture. Let's say convolutional neural network or a recurrent neural network. How do you see, or what is your comment on that kind of implementation for a RISC-V hard to operate with that much specification, so that much capability?
Hmm. That well, I guess like um, I briefly mentioned, the the vector instructions are um, you know uh, sort of vector length agnostic, and it just up to how how many elements a core chooses to implement. Like if you look at the vector extension and um, you know, you know, and the vector extension and how many memory elements are put into that in the core's implementation. I think I'm seeing a lot of people implementing. Look here, Anushka. Look for RISC-V vector extension. I think it's like 1024 elements. That's some great something because it in I can't remember the mnemonic of the instruction, but when the you sort of when you initialize or start to, defining the work with the vector, the length is just one parameter.
So what you were talking about, the RISC-V extension 1024 elements.
Well, yeah, that's the kind of a latest implementation.
But should I open the GitHub file?
I think that might be the one of the latest ratified specs. I think the current version is like Vector 1.0. Yeah.
Are you talking about this?
Exactly. Yes.
Yeah.
This is the SIMD equivalent, and there's a lot of people using the vector extension to enable AI, um, and different types of convolution kind of actively. That and also the matrix extension.
Yeah. Actually, few days back, only RISC-V had a meeting on AI accelerators also. So there also they discussed about this. So if we summarize a key thing which we discuss in today's meet, that we must keep up with the RISC-V meetings which are conducted regularly, and there's RISC-V community forum. So there, if you want to know that what's development going on with the tiling, what's the development going on with the different extension, different ISAs, keep you must stay updated with what is going in the community. So that will give you a better picture of what's going on in RISC-V. And being a part of that community, you can contribute your expertise also by contributing to RISC-V architecture, and and most importantly, becoming a member of RISC-V. Yeah,
Yeah. Wow. How do you do that? Very, crisp, crisp summary, Anushka.
yeah,
How did you do that? Yeah.
yeah,
Yeah. And there's a reason that RISC-V sort of has the Mona Lisa, because that's the symbol of elegance and simplicity. And elegance and simplicity in design. And you just nailed it in your elegant and simple summary.
yeah. So, is anyone having any more questions for today's podcast?
I might throw out a question if somebody has you know one. I think it's one of the things we sort of talked about, or where where will RISC-V where will RISC-V be, or where will we be in the next 5 years?
Yeah,
And my, I guess my my guess is that in the next 5 years we'll be at a place that when we happen, Anushka, when you happen to have a conversation in a party or at a bar, we don't go to bars, right? Um, and we strike up a conversation with someone on the street, and they ask, "What are you doing?" "I'm in RISC-V." Right now, you get a blank stare. Huh? Risk what? And in the next 5 years, when you say, I work with RISC-V, we won't get a blank stare.
very true.
And that's my guess, or that's my forecast, that it's like Linux. When Linux first came out, remember, we started from Gary Kildall and CPM, that went into PC DOS and MS DOS, everybody embracing Microsoft and Microsoft Basic and Visual. Okay, and then on the side there was Unix. Okay, you know not to say there's different types of Unix like BSD or or Berkeley Unix, but then through a little bit of work with Andrew Tannenbaum and learning Minix. How many people learn MINIX? This thing called Linux. In the early 90s and the 2000s, when you said Linux, people thought you're talking about you know uh, bed sheets, linens. Nobody knew what Linux was or who Linus Torvalds was. It you got blank stares, and now what you can say to somebody Linux, and it's, oh yeah, I know that. And
Yeah,
so RISC-V is going to be in the next 5 years or less. I think that RISC-V will will be just as common as Linux is now. That I like to think, if somebody asks me, how do you explain RISC-V at a cocktail party, you say RISC-V is the hardware equivalent of Linux.
yeah,
So
yeah.
in
We recently got to see that PC rumor is 5 laptop. So RISC-V is coming into the PC market also as well, right?
the PC market, the tablet market, DC Roma, what is it, direct computing or deep computing?
Yeah,
Yeah, DC Roma. And the I haven't bought it yet, but there's still a lot there. If you look on Arrow, okay, everybody who's still there and awake, I know it's late. Um, Search for Arrow P550 Sci5.
yeah,
You've seen that, Anushka, right?
Yeah, yeah, I've seen that.
It's $400. It's just like the DC Roma laptop or tablet. The P550 Sci5 quad core, um, very nice implementation, vector, very highly scalable implementation of the vector instruction set in there. It's only 16 gigabyte RAM, and it doesn't need that much RAM. And right away runs Ubuntu. I think Ubuntu is very good. Another challenge for because this is open source and including hardware that's not in open source, one of the biggest challenges for getting off the ground, not for academic training, like I mentioned, the importance to get Arduinos into schools like that, or Arduino-like things into schools, is BIOS. There's a very active effort, and anyone here that's good with operating systems and the higher level work, please, a lot of help is needed with understanding the UEFI and the open source BIOS nature. It's Canonical did a very good job working out the boot process from here. But remember, we're sort of trying to create an open source equivalent to the Phoenix BIOS and the AMI, American Megatrends. These, BIOS was something, the basic input output system, the first and second stage bootloader was something very not well documented and very proprietary. And so that's a very big area. What, who is going to contribute to making sure we have a open source RISC-V BIOS, so that something like an iOS or iPad OS could be done.
Yeah.
Yeah. So if it's $399, $400. If you did get a board and try to bring it up and you have trouble with the bootloader, don't fret, don't worry, because a lot of people have the same problem. Forums.sci5, another area that I have a lot of contribution to that everybody here should look at is forums.sci5.com. A wealth of specific technical communication, wealth of knowledge. So RISC-V.org is the standards, the community, the calendar, tech.riscv.org/calendar. Forums.sci5.com is groups that you see the P550, you see the High Five One board is a little bit old, and my contribution is I'm user PDS. You can see my contribution there.
Yeah.
And on GitHub, for those that have seen Finding Nemo, like Paul Sherman, 42 Wallaby Way, Great Barrier Reef. So most of the contribution on Sci5 is around the FE310 that I put there.
Yeah.
But
That's
if
interesting.
anybody did get into UEFI, remind me, Anushka, or anyone else here, what's the other open source bootloader that people work with?
Yeah, okay.
Oh, oh, U-boot. So UEFI and U-boot are, again, another very active part of the community work being done at the high level. And so at the low level, there's the documentation, simple single core, modular nature aspects. And then at the high level, the systems operation. UEFI, U-boot, biggest challenges. And the two outstanding areas that are not, you know, not not really worked out is OpenGL and PCIe root complex and DRAM interface.
Yes.
Root and so that needs some community driven focus. PCIe root complex, um, uh, DRAM controller. The DRAM controller are highly proprietary, and that's an area of open work. UEFI, U-boot, um, and so GPU kind of open, GL or or graphics processing stuff. Like when you look at the open source Raspberry Pi, the graphics engine processor, it's always a binary object, right? Blobs in there. You're given an API, but the internals are not exposed,
Yeah.
and
Okay.
so no no blobs.